for this set of notes, you can title it Creating an Equation to Represent Data. You will notice typically whenever I record, I will have information already written. That way you're not sitting there waiting for me to record it. But the nice thing about me recording videos is that you can pause it. So if you are going to take time to write this down, so that you have enough time to write this down in your notes, pause the video and then write this down. That way whenever I'm explaining things and writing things, you can always do it with me. So notice we have number of toppings, 0, 1, 2, 3. This is talking about a pizza, and then it's talking about the cost of the pizza. So if I have 0 toppings, it's still going to cost me $7. Some people are always like, well, why am I paying $7? Even if you get a cheese pizza, they're going to charge you to get a cheese pizza. It's just that you have 0 toppings. If you had 1 topping, you'd pay $9, 2 toppings, $11, 3 toppings is $13. So the first thing that I want you to do is write the verbal description. So verbal description. So based on what's happening in this table, we want to write a verbal description. So if we look, for every 1 topping, the cost is going up $2. 9 minus 7 is 2. So we can say the cost increases $2 for every topping, and those are expensive toppings. But we also have $7, and it costs $7 for a plain pizza, or a pizza without any toppings. So that's our verbal description. Once you have your verbal description, it makes it a lot easier to do these next steps. So again, we're writing equations. This process is just going to help us write the equation. So process is used to help find the equation to get from the independent to the dependent. Sorry, my handwriting was not very pretty. That's an E. Okay, so the process is going to help us get from T, so for any number of toppings, to the cost. So the first thing that you're always going to see me do is write out. So from 7 to 9, it increased $2. From 9 to 11, it increased $2. From 11 to 13, it increased $2. So if I'm wanting to know how to use this information to give me my cost, so notice I'm wanting the equation. What I mean by wanting the equation is I'm wanting to say, so if I know my number of toppings, so I have 1 topping, what could I mathematically do to get from 1 to 9? So you're going to use this number. It stopped recording, so I'm adding an extra clip on. So we're going to say 2, and then we're going to put times this input value. So 2 times 0, because again, we haven't paid anything. We have no toppings on this one. So it's $2 for every topping. Well, I don't have any toppings, so 2 times 0. And then it costs $7 for the pizza. So if it's $2 for every topping and I don't have any toppings, it'd be 2 times 0 toppings. 2 times 0 is 0, plus 7 would give me 7. Now let's try it on the next one. It's $2 for every topping. I have 1 topping in this case, so 2 times 1 is 2, plus $7 for the pizza. So 2 times 1 is 2, plus 7 would give you 9. Okay, again, try the next one. 2 times 2, 2 times 2 is 4, so it's $2 for every topping. I have 2 toppings, so 2 times 2 is 4. And then plus $7 for the original pizza. 2 times 2 is 4, plus 7, 7, 8, 9, 10, 11. So it would be $11. Then we're going to do 2 times 3, which is 6, plus 7, 7 plus 6. 6 plus 6 is 12, plus 1 more would be 13. So now, to write our equation to get from the independent to the dependent, you would say 2 times t, so 2 times any number of toppings. We don't have to know the number of toppings. We're just trying to figure out an equation that would get us from any number to the cost. So 2 times 7, notice the 2 stayed the same. It was 0, 1, 2, 3, so that's the variable. And remember, any number could be used there. I could use 100 toppings. If you wanted to put every single topping at the pizza place, you could totally put every single topping. And then remember, it's $7 for the pizza. So we're always going to do 2 times t, which is the number of toppings, plus 7 will give us our cost. Something to think about or remember, 2 times t, we don't have to write 2 times t. We could just write it as 2t, because when you have a number and a variable right next to each other like that, plus 7. Okay, remember this 2 was used right there. 2 was the cost per topping. And then the 7 was the cost without any toppings. I'm sorry, it's lunch and you can probably hear the screaming going on outside. So that's where all of these numbers came from. You will notice that all of a sudden there's a whole bunch more information. Remember, pause the video whenever you're done writing everything down from the video, then resume the video, and that way you're ready for me to explain. So I'm going to move on. So if you remember the matchsticks, so this is 1 square. Notice we used 1, 2, 3, 4 sticks. If we have 2 squares, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, I miscounted, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's where all of those numbers come from. I'm going to use pencil for, sorry, the lunch just ended. I'm going to use pencil to do this part for just a minute, or in just a second, so pay attention to when I'm using pencil because I am going to erase some stuff. So if we notice from 4 to 7, 4 to 7 increased by 3. There were 3 additional sticks. This 1, 2, 3 additional sticks. And then we have 7 plus 3 gives you 10. That's 1, 2, 3 additional sticks. Then we have 3 more, which is 1, 2, 3 additional sticks. So, based on what we just did in the pizza toppings one, you would do 3 times 1, and notice I'm going to use pencil. So 3 times 1 is 3, but we need to get to 4. So the process, sometimes it's not as easy to find it like in the pizza toppings one. Sorry, my recordings just keep stopping and I keep having to resume them. But and when that's the case, sometimes you have to do a little bit of math to figure out the rest of it. So if we have 3 times 1, that's 3. Notice I'm using pencil because I might need to erase in a second. So I have 3, but I need to get it to 4. So I need to mathematically think about from 3 to 4, what do I need to do? Well, in this case, I just need to add 1. So I'm going to say plus 1. And let's see, so 3 times 1 is 3, plus 1 is 4. Well, let's try it on the next one. If I have 3, and you will notice I switch colors a lot, that's the whole thing about the colored pens. 3 times 2, so 3 because there's a 3 additional, times 2 squares. So 3 times 2 is 6. Well, look, I need plus 1 more to give me 7. So 3 times 2 is 6, plus 1 is 7. Now, let's continue and see if the pattern keeps working. So we have 3, notice that 3 is always there, times 3. 3 times 3 is 9. 9 plus 1 would in fact give me 10. 3 times 4. 3 times 4 is 12. Plus 10. Oh, I wrote plus 10, I'm sorry. Sorry, that should have been plus 1. Okay, so it's plus 1. And if you need to borrow whiteout, I always have whiteout. So 12 plus 1 is 13. That's correct. So let's finish writing it. So now it's 3 times n. N is the number of squares. We're using P for popsicle sticks. Make sure you always identify that. So 3 times n plus 1 is going to give me the process. Now, think about where this 3 came from. 3 was the additional sticks needed. Now let's think about that 1. So if I have 3 times 1, notice there's a group of 3 right here, plus 1 stick. So there's a group of 3 plus 1 stick. So 3 times 1 plus the 3 times 1 plus 1, because that 1 additional stick. Now look at this one. We knew that there were 3 additional sticks here, but if I was just saying I have 2 squares, so I was looking at this one and this one only, if I said I have 2 squares, I could think of this as 2 groups of 3 and then that first stick. 3 times 2, 3 times 2 is 6, so I have 6 sticks right here, plus that first stick that made that first side. So the 1 here is the first, oops, I can barely see that, the first stick needed. So our final equation would be 3n plus 1. And some of you guys got that on the activity, I believe, if I remember correctly. So 3n plus 1, you can say however many squares I have times 3 will give me 1. So if I wanted to find the 11th one, I could do 3 times 11 plus 1. 3 times 11 would be 33, plus 1 is 34. So I would need 34 sticks if I had 11 squares. So again, your equation helps you be able to just move from this to that without having to actually lay out or draw 11 squares on your paper. So now I want you to practice that on the practice assignment.